Hello, my name is Pablo, this over here is Milo, and today we're going to do a tutorial about a wet shader. A lot of this wet tutorial is based on this talk by Naughty Dog from Siggraph 2016, so props go to Waylon Brink and Andrew Maximov. So I show here an example of wetness versus dryness, which they have down here. It's kind of hard to see the difference when it's a still image, but you can actually see that certain zones are darker, particularly in the walls. You can see like the streaks of like darkness, which means basically those streaks is kind of as if water was running down. And there's a little bit of sheen on the ground, but it'll be easier to see once we see it in movement. So over here we have the demo that I made in Unity. This is using an asset from the asset store called Kawaii City, I believe it is called, something like that. And right now basically I applied the wetness material to everything except for the street markings and the windows. Obviously it looks dry at the moment, but then if I increase the wetness you can see it basically starts coming in, and you can start seeing like puddles in the ground and a little bit of the reflections, the difference between like the areas that are more soaked and the areas that are a little drier. Same over here, and you can see a little bit of the reflections. The reflections are super simple right now. It's just using the reflection probes that were there by default. You can definitely make this better if you use like screen-based reflections, or if you use even positioning the probes a little nicer would make them better, but it does look pretty nice. And I can also like tone down the wetness. So for example, you can start dry and then you could put like some, rain effects or something as everything starts getting wet, and then you get kind of this effect a little stronger. So in their talk, Naughty Dog actually shows this diagram, which I think is very useful to understand what we're trying to do. So basically we're going to have 4 different zones. Zone A basically is anything that's all like submerged by water. So it's a puddle at that point. So what does that mean? It basically means we want it to be reflective. We want it to basically have a totally flat surface. We don't want any normals there. Then on zone B, you got that sort of like shiny part, and the way that they describe it is basically this is where the water would be like holding on to the material underneath it because of surface tension. So it gives it kind of a glossiness. I think they call it like saran wrap look or something like that. So basically that part also has the shininess, but it still respects some of the normals, although it has kind of softened them a little bit. Then the C is basically where it's just darkened. And what they're trying to represent with that zone is essentially if there's a porous surface, the water has soaked in and therefore kind of darkened that area. And finally D, that's where it's totally dry. So those are kind of like the 4 zones that we're going for to get that effect of wetness. And in this slide, they actually show the shader that they're going to use. I'm actually going to link to this slide down in the description so you can read it out. It actually is a very interesting document. It not only has wetness, but it has other things like how they render moss, how they render glass. It has a whole bunch of things, so it's very, very interesting to read. The shader that they're doing here, I'm gonna use some of the ideas. I'm not gonna do it like one to one on Siggraph. It's gonna be similar, but it won't be exactly the same. So depending on what you need, you might wanna get closer to theirs or get closer to the one I'm implementing. So the way it starts for them is they have this wetness mask, which basically is what tells us what is wet and what is dry. And they're doing this by making textures for each one of their assets that can describe which areas would be wet and which ones wouldn't be. So for example, in the rocks over here, you can see anything that's black means it's dry. This gray over here would be wetter. But if you look at this rock down here, which has a lot of like really bright colors, that means this is very, very wet, but these plants over here are very dry. So that's kind of how they handle the wetness mask. Now, I don't have any wetness mask on my assets, so instead of that, essentially I'm doing a procedural wetness mask, which obviously is not as nice as an artist-made one, but it does the job. So the way I'm doing my wetness calculation is basically I'm just doing a noise over all the things, and that kind of gives that puddle look because, just a noise kind of does like a cloudy look between whites and blacks. And then basically I'm applying some dot products to make sure that like a floor can be fully wet, but a wall cannot be fully wet because obviously it's perpendicular to the ground, so the water kind of falls, and a ceiling cannot be wet at all. So those are the main things that I'm doing to it. So over here you can see a preview of the wetness mask. Essentially you can see the noise in the ground, and then you can see walls like this essentially are gray, same for this parts, so you don't want this parts to ever be white. And then things like inside of here, this is fully black because a ceiling cannot be wet. Now here's where you can see the first problem with doing this procedurally instead of doing with an artist. For example, this wall is wet, which makes absolutely no sense, right? How did the water get out there? This wall as well, those are all like just as wet and this as this outside walls. So obviously the solution for that is you could just put a material in there that is not wet. But you know, if you have an artist that can do this nicely, then for example for the staircase they could do like black for the wetness up here, but then put a little like a gradient of white to gray here so that it looks like it's getting wet on the entrance, and that gives a much more natural feel, right? That's the sort of thing that you could get with an artist that in this case with just some procedurally thing is not as nice. So to calculate the noise, I'm not using UV coordinates. Instead of that, I'm actually grabbing the absolute world position of what I'm drawing. The reason for that is if you use the UVs and then you put two objects next to each other, you'll actually be able to see the seam between them. So let me show you that. If I just disconnect this one from here, the scale is going to be a little different. So let me change that to like a 25. So you can see here, if I use the UVs, actually you can very clearly see the tiling between one object and the other, whereas if I'm using the absolute world positions, it's all seamless when I'm generating that noise. This is useful not only for this shader, this is very useful in general. Whenever you're going to do a shader that goes across multiple meshes, it's much better if you can use something like the world position. That way the numbers are consistent across all objects. After that, we apply a power to the noise based on wetness, and basically what it does is whenever you apply a power to a number that's between 0 and 1, it actually compresses it. So for example, imagine you have 0.5 to the power of 2, that's 0.5 times 0.5, which gives you 0.25. So actually it kind of compresses the numbers down. And then those are the ones that we're using to kind of calculate our wetness. The one interesting thing that I can show you here that applies again for any shader you ever want to make is that wetness is marked here, so you can see it is a property, but it doesn't it's not marked as exposed. And the usefulness of that is that then you can use it as a global variable for all your materials. So in this case, you have seen that I've been changing the wetness of the whole level at once. I can use this color here, shader.set global float wetness, and then I just pass the wet amount, and that way every single material in the level that's using that variable will essentially take that value. So it's a nice way to declare anything that you want that might be global to your shaders. Then down here I do what I was talking about earlier. Basically I'm grabbing the normal vector and then I'm doing a dot product from it to the up vector, which is just y looking up, and that's the way I can decide, okay, is this a floor, is this a ceiling, is this a wall, and then I'm remapping that from -1 to 1 to 0 to 1, so that 1 is a floor, 0.5 would be a wall, and then a ceiling would be 0, and that way I can determine how much do I affect the existing wetness by it. And then after that I just saturate it. In case you're not familiar with saturate, saturate just basically is a clamp from 0 to 1. I probably don't need it in this case because it's already been saturated and I'm multiplying it by something that comes from 0 to 1. But you know, just in case, every now and then I like to throw in saturate just to be sure. I remember at some point I didn't actually know what saturate did. And I remember my boss every now and then would tell me like, hey, have you tried putting a saturate there to fix this or that? And I would just throw it in without knowing what it was. And you know, and I find myself just throwing saturates willy-nilly all over the place to try and fix things. Why did I just explain that? I did not need to explain that in a tutorial, but the next thing we need to calculate is porosity, and that basically means how porous the material we're working on is. So for example, cement would be very porous, so that means it absorbs a lot of water, but something like glass is not porous at all, so it doesn't absorb water. Now they say they have a control parameter, but it's not clear to me if they have a map for this or not. Anyways, I cannot have maps because I don't have an army of artists to make this, so what I'm using is what they're suggesting is using the roughness instead. Unity doesn't use roughness, it uses smoothness, but smoothness is just roughness inverted, right? So if something is really rough, that means it's not very smooth, so you just flip it and you got it. So since we're going to use the smoothness for this, essentially we grab the metallic map, the smoothness is in the alpha channel of that, and then we also have like a variable that we can use to regulate how smooth this particular material is. We invert it because again they wanted roughness, which is the opposite of smoothness, and then we remap it to a value between 0.35 and 0.6. These are values recommended by them for porosity, but you can tweak those to get like the proper feel that you want. Then for the albedo, we will basically just grab the albedo, we sample it, we multiply it by a color just in case you want to tint it, and then we do two things. First, one of them we just power it to, in this case, 2, and that does, as I said earlier, whenever you do power on a value between 0 and 1, you basically compress it, so basically you're making it darker. When it's a color, you're making that color darker. And then we do a lerp between the normal color and this darker color based on the porosity multiplied by the wetness. So the wetness is coming from here, and then we're doing a little process here, which is this clamp range. Let me show you. So basically where the wetness comes in, we're grabbing a range, and then we turn that into 0 to 1, and then we're just saturating it. So what that means essentially is that any value that's 0 or below will be 0, any value between 0 and 0.35 will interpolate from 0 to 1, and then any value above 0.35 will become 1. So that basically you're saying anything that's above 0.35 wetness, we want it to be fully darkened. So after we calculate the albedo, I'm doing this part which is a rim calculation. They don't do this for the Naughty Dog one, so I'm gonna wait until the end to explain this part because this is totally optional, so I'll leave it to the end. Over here we calculate the normal, and basically we're getting the wetness just like we did with the albedo. Then we're clamping it just like we did again with the albedo, and we're saying anything below 0.6 we leave at 0. So basically we're not going to modify it. Anything between 0.6 and 0.9 we're going to start affecting the normals there, and then everything above 0.9 we're going to totally flatten those normals. So basically we grab this value, we flip it, and then we apply that to the normal strength. So that basically means that if it was 1, this turns into 0, which means the normal strength will be 0, so totally flat. Okay, so now basically to show what the normals do, basically what I want to do is once things get within the water, like once they're soaked in, we want them to flatten. So for example here in the middle you can start seeing how the normals for this sort of rough, the rough normals that this has, starts getting kind of flattened. You know, you don't see the same roughness over here because now this is underwater. So if I continue going and making everything a little soaker now, it looks like this entire part is flat, whereas this still has that like saran wrapping thing that I was talking about. And then over here you can see like all the texture of the normals like at full strength. So basically that's what we want to do. We want to flatten all the normals on things that are underwater, and you can see the effect over here is pretty nice to see. Like this puddle does look kind of like a puddle because it's flattened those normals. And then the calculation for the smoothness is very similar to what we're doing. Again, we grab the clamp range, which basically means anything below 0.2 remains as 0, then it lerps from there to 0.1, and then anything above 1 is just turned into 1. And then I'm lerping that to the smoothness that I get from the metallic. Then for the emission, I literally just take the regular texture for the emission and then just multiply by a color, so I'm not even touching it by the wetness. And for the AO, I'm also not touching it by the wetness, but you can totally do it. The reason I'm not doing it in this case is just because none of the materials I have actually have AO, but if you do have AO, you definitely want to do it. You can see in that Naughty Dog document they're doing like the same operation, essentially kind of the same thing that we're doing here for smoothness, just different ranges, but it's the exact same idea. And finally, let me explain the rim calculation. This is totally optional. The main reason I did it is because the assets I have here are a little more stylized, so it kind of helped me to have like a little bit of a rim around the water. I just felt like it looked nicer and matched the assets better, but this is totally optional. The Naughty Dog one doesn't do this at all. So the rim, let me show you what it's done. Right now I have it as white, but just so that it's super obvious, let's make it red, and let's increase the amount of it. And then as I make things be wet, you can see that's basically the rim. As things start to get soaked, I start putting it in, and I have control over, you know, how opaque it is, like you were seeing earlier. You know, I can tweak it in and out. I generally, like the way I was using it was just like a low gray at a very low alpha, just to kind of give that little aspect around the edge. I can also adjust like when exactly it comes in, if I want to adjust the position, if I want to adjust how much width it has, or how soft it is. You know, you can tweak all sorts of things. So the way I calculate the rim, essentially, basically, I just take the wetness, I do a couple smooth steps, basically one above and one below, and then I combine those two to make like that little rim that you saw, and then I multiply that by the color, and then last but not least, I add that to the original color that we had on the albedo, and that's it. That's basically the whole thing. It looks like a lot, you know, whenever you do a shader in Siggraph, it just kind of balloons, you know. You compare this with their, you know, 10 lines of code, it does look like the Siggraph makes it a lot more. So that's basically it. As you can see, it's not a super complicated shader, but it actually manages to look really cool. Like it actually looks like, you know, it's been raining and stuff. Of course, you can tweak it a lot based on if you want that rim stuff or if you don't, if you have the ability to generate some wetness maps, or if you just want to do the procedural version like I did. There's a lot of it to mess around with and enjoy. I hope you enjoyed it. I hope you learned something. If you ever want to catch it, this actually was recorded during a stream on twitch.tv/PaoloMakes. Hope to see you there. Take care. Adios.
Well, thanks for stopping by. Don't forget to like, subscribe, and hit the bell to be notified when new videos come out. Thanks for watching.